channel. In today's video we are going to learn about some interesting and the challenging examples by which we can calculate the oxidation number of the atom. So in the previous lecture we have calculated the oxidation number by using your rules 1. Now here you are going to use the same rule, but you have to consider the structure of that compound, then and then only we will calculate the exact oxidation number 1. So this is the new thing that we are going to learn today 1. So let us start with the first example. Example number first, NH4 NO3. Okay. No doubt we have to calculate the oxidation number of nitrogen atom. Okay. Now before considering the nature of this particular compound, if I am going to calculate the oxidation number, now how we can calculate the oxidation number? For nitrogen atom we are going to consider X as an oxidation state, as the nitrogen atom 2 times, therefore 2X plus here 4 hydrogen atom, we know that oxidation number of hydrogen atom is plus 1. Okay. Now for our oxygen atom, obviously 3 into minus 2. So these are the oxidation states 1, no doubt. Okay. Now if the oxidation number, by the oxidation number, that will be equals to 2x plus 4 minus 6 equals to 0. Therefore 2x minus 2 equals to 0. Therefore x will be equals to plus 1. Okay. That is simple method by using our simple rule 1. But remember, particular example we have to consider the nature of this particular compound. Generally your NH4NO3 is made up of NH4 plus ion and NO3 minus ions 1. Okay. So this is your ionic compound. If we dissolve this particular compound, obviously there will be the formation of NH4 plus and NO3 minus. So these are the two ions by which it is made up of 1. Now let us calculate the oxidation number in this NH4 plus ion. Okay. NH4 plus ion, if I am going to consider the oxidation number, how I am going to consider the oxidation number? It is very simple. Now consider for just NH4 plus ion 1. Okay, obviously let the oxidation number of nitrogen equals to X, and we know that the oxidation number of hydrogen will be equals to plus 1, obviously. Okay, and we know that this NH4 plus ion is a cation, hence the oxidation number of all atoms in monoatomic ion equals to charge on it, that will be plus 1. Now hence we can write this as an oxidation number of nitrogen plus oxidation number of hydrogen equals to, obviously how much? Equals to plus 1. That is nothing but charge on the ion 1. Now let us put the values. X plus, how many hydrogen atoms are here? 4. Therefore 4 times into, that is your oxidation number plus 1, which is equals to again plus 1. We know that the oxidation number of hydrogen atom when it is attached with the non-metal, nitrogen is your non-metal, and hence this oxidation number considered as a plus 1. Therefore X plus 4 equals to 1. Therefore X will be equals to 1 minus 4. Therefore X will be equals to minus 3. So here we can write, hence the oxidation number of nitrogen in NH4 plus ion equals to minus 3. Now let us consider for next ion. Now here in NO3 minus ions. Okay, now how we can calculate? Again, very simple one, you have to write down in this steps wise manner one. Let the oxidation number of nitrogen equals to X. Okay, then the oxidation number of oxygen in all of its compound equals to -2. Okay, now and we know that NO3 minus is a anion and its oxidation number equals to charge on it, that is -1, and hence we can write it as an that is oxidation number of nitrogen plus 3 into oxidation number of oxygen, which is equals to -1. Now obviously oxidation number of nitrogen we are going to consider it as an X plus 3 into oxidation number of oxygen equals to -2, which is equals to -1. Okay, let us do the simple mathematical calculations, that is X minus 6 will be equals to -1. Therefore X will be equals to -1 plus 6, therefore X will be equals to plus 5. Okay, the oxidation number of nitrogen in NO3 minus ion will be equals to plus 5. Okay, as we know that we have calculated the oxidation number of nitrogen here. Okay, and now here also for NO3 and for NH4 plus it is plus 3. Now it is it is -3, it is plus 5 1. Now but the molecule which is given here is electrical neutral, that means it is neutral in molecule. Let us find out whether that molecule neutrals or not one. Now here the oxidation number of nitrogen is -3. For 4 hydrogen that will be equals to plus 4. Okay, now again for this nitrogen that is plus 5, and for oxygen that will be equals to -6. 2 into 3 into -2 equals to -6 1. So obviously -3 minus 6 will be -9. Okay, -6 minus 3 will be equals to -9. Now 5 plus 4, that means plus 4 plus 5, that is equals to plus 9. So it is 0 1. So this is the method for solving this particular example. Now that is our example number 2, that is given as an H2SO5. Another very important example. Now here if we calculate directly the oxidation number for sulfur, no doubt here we have to calculate the oxidation number of the sulfur one. So without considering this structure, if I calculate the oxidation number of this particular molecule one, that will be equals to, let us consider, that is plus 1. Okay, that is equals to -2 into plus 1 for your hydrogen atom, X for your sulfur atom, plus 5 into oxidation number of oxygen atom will be equals to -2, which is equals to 0. Okay, now let us do simple mathematical calculation, that is plus 2 X and -10, which is equals to 0. Therefore X minus 8 equals to 0, therefore X will be equals to plus 8, which is a wrong answer one. Okay, before considering the structure of this particular, let us start with this solution one. I will draw the structure first of all for this molecule one, that is OH, S double bond O, S double bond O, and that is nothing but your OOH, that is nothing but H2SO5. Okay, 1 2 3 4 5. Again remember students, if I consider the structure of this particular molecule, I have found that the two oxygen atom in this molecule forms which linkage one? That is nothing but your peroxide linkage one. This linkage is your peroxide linkage. Okay. Now we have studied the rule for oxygen atom. Now which is that rule? The oxidation number of oxygen atom in all of its compound is -2, except in peroxide and the superoxide its oxidation number is -1. So now let us calculate the oxidation number for sulfur by considering the structure one. So let the oxidation number of sulfur equals to X. Okay. Now the oxidation number of 1, 2, 3. Okay. For 3 oxygen atom equals to -2. Okay. Again, what about the 2 oxygen atom? The oxidation number of 2 oxygen in peroxides equals to -1. Okay. And lastly, the oxidation number of hydrogen equals to +1. Okay. Now we will not write the whole equation. What we are going to write now? 2 into oxidation number of hydrogen. So I will represent in the form of symbol plus oxidation number of sulfur. Okay, that is sulfur plus 3 into oxidation number of oxygen. Okay, plus 2 into oxidation number of oxygen, and now I will write it as an peroxide oxygen. Okay, differentiate one. Now, so everything is over. We know that this particular molecule is a neutral in nature. So write down here, you can simply write down here H2S2O5 is a neutral molecule which is its oxidation number equals to 0, 1. This practice you can easily write down this one. So obviously just put up the value and find out the answer one. So 2 into oxidation number of hydrogen as an +1, plus for sulfur we are going to consider the oxidation number as an X, plus 3 into oxidation number of -2 for 3 oxygen atom. Okay, which is shown here, this one and this one. Now rest of the 2 oxygen atoms, okay, now this one, now they will show the oxidation number as an -1, which is equals to 0, 1. That's it. Therefore 2 plus X minus 6 is 2 equals to 0. So this is our simple mathematical equation, a plus minus calculations one. Therefore it will be equals to X minus 6 equals to 0. It will cancel out. Okay, so therefore X will be equals to plus 6. So here again we are going to write the oxidation number of sulfur in H2S2O5 equals to plus 6. Now again you can do the tally. How you can do the tally? Oxidation number of hydrogen atom, oxidation number of sulfur, and oxidation number of oxygen must be equals to 0, as it is the neutral molecule one. So here we are going to consider +2. Okay, plus sulfur, how much we have calculated? Plus 6. Okay, and for 5 oxygen atom, okay, 3 have a -6 value while 2 have a -2 value. Okay, so -2 plus 2 cancel out, -6 plus 6 will cancel out, and hence this whole molecule is a neutral in nature. So this is your simple method. So now let's start with the example number 3rd, that is CrO5. Okay, that is your chromium peroxides compound one. Okay, now here the structure of your chromium peroxide is like this: Cr double bond O, single bond O, again single bond O, and again O, single bond Cr, O, O. So this is a butterfly structure one, is it right? Now here you can simply identify it now. Okay, that I have shown here, okay, is nothing but your peroxide linkage one, and this is your simple oxygen atom. Find out the oxidation number for it one. So how we can find out? Let the oxidation number of chromium will be equals to X. Okay, now next, the oxidation number of how many peroxide oxygen atom? 4 peroxide oxygen atoms will be equals to -1. Okay, now next, the oxidation number of one oxygen atom will be equals to -2. Is it right? So after writing this particular equation, now we can find out the oxidation number in the simple manner, that is oxidation number of your chromium plus 4 into oxidation number of oxygen, but that oxygen atoms are your peroxides one. Okay, plus 1 into oxidation number of oxygen atom, that is our simple oxygen atom one. Okay, and which is equals to, as this molecule is a neutral, so again I am forgetted here to write, that is CrO5 is a neutral molecule. Okay, therefore we can write Cr, oxidation number of chromium equals to X, plus 4 into oxidation number of peroxide oxygen equals to -1 according to our rule, plus 1 into -2 for your oxygen atom. Okay, now do a simple mathematical calculations, that is X minus 4, 1 into -4 will be -4, plus 4, 1 into -2 will be equals to -2, therefore equals to 0, therefore X minus 6 will be equals to 0, and therefore X will be equals to plus 6. So that is our answer one. Okay, now again just write down this statement and tally your answer with this particular example one. So here we can write the oxidation number of chromium in CrO5 will be equals to plus 6. Okay, so by considering this particular structure, we have find out the oxidation number as an plus 6. But if in the exam you forget about this structure, how much number you will going to calculate? That is X minus 10 equals to 0, therefore X equals to plus 10, which is a wrong one. Okay, so remember, so these are the some challenging and the interesting example. Here we have to consider the structure of this particular compound one. So now let's start with the example number 4th. Okay, that is your H2S2O8. Okay, now I will draw the structure for this particular molecule one. So the structure is like this: OH, S, double bond O, S, double bond O, S, double bond O, then O, O, then again S, double bond O, S, double bond O, OH. So now after drawing the structure, it will be very easy one. So this is nothing but your peroxide linkage one. Is it right? So obviously its oxidation number will be equals to -2. So just write down this in the stepwise manner and find out the answer. It is very simple. We know that we are going to calculate the oxidation number of a sulfur here. Let the oxidation number of sulfur equals to X. Okay, just find out how many oxygen atoms are your simple oxides one, okay, or simple oxygen atoms, and how many are the attached by the peroxide linkage one. So here 1 2 3 1 2 3, okay. So 6, the oxidation number of 6 oxygen atom will be equals to -2. Okay, that will be equals to your -2, while the oxidation number of 2 oxygen atom, that will be equals to -1. And lastly, the oxidation number of hydrogen atoms will be equals to +1. So here we can write the equation in such manner: 2 hydrogen atom, therefore 2 into hydrogen atom plus, okay. Now how many sulfur atom? 2, therefore 2 into sulfur plus, okay, 1 2 3 1 2 3. So total 6 oxygen atoms. 6 into O, that is our oxygen atom, okay, plus this is about your peroxide oxygen atom one. So that is nothing but 2 into oxygen, and which is your peroxides one. As this molecule is neutral in nature, therefore its oxidation number equals to 0. So again write down here simply, therefore H2S2O8 is a neutral, therefore its oxidation number will be equals to 0. Now just put up the value and find out the answer one. So here 2 into oxidation number of hydrogen is +2, plus 2 into oxidation number of sulfur is considered as an X, plus 6 into oxidation number for your simple oxygen atom equals to -2, plus 2 into oxidation number of oxygen atom equals to -1, which is equals to 0, 1. Therefore 2 plus 2x minus 12 minus 2 equals to 0. Therefore plus 2 minus 2 will get cancelled out. Therefore 2x minus 12 equals to 0. Therefore 2x will be equals to plus 12. Therefore x will be equals to plus 6. So again we are going to write down the statement: the oxidation number of sulfur in H2S2O8 molecule equals to +6. Now first of all put up the values here again and find out whether that molecule is neutral or not one. Simple. We know that 1 2 3 1 2 3. So total 6 oxygen atom, therefore 6 into -2, that will be equals to -12. 2 peroxide linkage, that will be again -2. So -12 plus -2 will equals to -14. Now 2 sulfur have the oxidation number as an +12, plus for 2 hydrogen atom, that will be equals to +2. So that is again equals to +14. So -14 plus 14 will cancel out. So its oxidation number will be equals to 0. So this is your neutral. It is considered with example number 5th, your CaOCl2, that is our bleaching powder. that is your calcium hypochlorite. Okay, now if I'm going to consider the structure for this one, that is CaCl, again OCl. So this is a very simple example one, but it is a little bit challenging. Okay, now let us consider this solution of this particular example one. Let the oxidation number of calcium equals to X, then again oxidation number of chlorine, all halogen will have the oxidation number -1. Okay, oxidation number of oxygen will be equals to -2. Okay, and obviously the oxidation number of chlorine will be equals to +1. So this is simply one rule which we have learned. One, whenever the halogen atom attach with the oxygen compound, okay, its oxidation number is considered as an +1. Okay, again this molecule is neutral, so your CaOCl2 is a neutral molecule, therefore its oxidation number will be equals to 0. Now let us find out the answer very simply, that is X for your calcium. Okay, now after doing this much practice, okay, we will directly write down the equation and find out the answer for this example one. Okay, so for X for your calcium, now for one chlorine atom its oxidation number will be equals to -1, therefore I will write it in the square bracket, -1 for this chlorine atom. Okay, now for oxygen atom oxidation number will be -2. Okay, and for this chlorine atom oxidation number will be equals to +1, which is equals to 0 as it is the neutral molecule. Now do the mathematical calculations. -2 -1 equals to -3 +1, which is equals to 0. Therefore X -2 will be equals to 0, therefore X will be equals to +2. Okay, so here calcium in your bleaching powder, that is CaOCl2, is having the oxidation number +2. So again this is a simple solution for this one. Now find out whether that molecule is neutral or not one. This is for our tally purpose. Okay, +1 -2 -1 +2. Okay, +2 -1 will cancel out, +1 -2 will be cancelled out. Okay, so it is neutral, its oxidation number equals to 0. So now example number 6, that is FeCO 5 times. Okay, this is the example from your metal carbonyls one. So here is nothing but your carbon monoxide. Okay, so your carbon monoxide is a neutral molecule. Okay, now if it is neutral molecule its oxidation number equals to 0. So let the oxidation number of Fe will be equals to X. Okay, and the oxidation number of carbon monoxide will be equals to 0. FeCO 5 time molecule is a neutral. Okay, which is equals to 0, 1. Okay, remember student, here your carbon monoxide molecule act as a ligand. Okay, now that ligand term is come under the chapter coordination chemistry. Okay, generally ligand have tendency to donate the lone pair of electron to your metal atom one, and so there is a formation of this FeCO 5 time molecule takes place, and this is actually the example from your coordination chemistry one. Okay, so here 0. Now write down the equation, hence we can consider the oxidation number of Fe equals to X plus 5 into oxidation number of your carbon monoxide, which is equals to 0. Therefore X plus 5 into 0, which is equals to 0. Therefore X will be equals to 0. Is it right? So here the oxidation number of, therefore the oxidation number of Fe in FeCO 5 time molecule is 0. Okay, so your oxidation number may be 0, don't worry. Okay, so this is about your example number 6. Now let us start with the example number 7 from again your coordination chemistry. Now let me tell you what is coordination chemistry. Now for your convenience, to solve this particular problem, you just remember coordination chemistry consists of one metal atom to which the ligands are attached. Okay, M for my metal atom and L for ligand, and N for how much ligands are attaching one, either 1, 2, 3 and 4. Okay, so this is this particular compound which is represented in the coordination chemistry known as a coordination compounds one. Now here metal takes the electron from your ligand, and ligand have tendency to donate the electron to the metal atom, and they form a covalent coordinate bond, and which result into the formation of your coordination compound one. So these are the few examples which is very essential, which is very important. How to generally find out the oxidation number for the metal atom one. That's why I have taken this particular example one, that is K3, then Fe Cn 6 time. Okay, again I will tell you one important thing. If you find the example in this type, whatever may be the entities which is written inside this square bracket, that is nothing but your coordination sphere one. It acts as an ligand. Just keep in your mind one. Now again find out the solution. We have to find out the solution in the similar manner. Nothing is new here. Okay, but the example is little bit challenging as you have not studied the coordination chemistry, or those who don't have the knowledge of the coordination chemistry one. Okay, so let us start with this solution. So we have to calculate the oxidation number of your iron here one. Let the oxidation number of Fe will be equals to X. Okay, now the oxidation number of potassium will be equals to +1. Now why this is +1? According to the note that we have considered in the previous lecture one. Remember, this is your first group element, and first group element shows the oxidation number +1. Now here this particular coordination compound is formed by the donation of lone pair of electron to the Fe1. Generally here your cyanide ion is in the form of a Cn-1. Okay, so here the charge on that particular ion is nothing but its oxidation number. Is it right? We have studied that rule one. So therefore the oxidation number of Cn- will be equals to -1. Now hence write down the equation, that is 3 into oxidation number of potassium plus oxidation number of iron plus 6 into oxidation number of Cn-, and this is again, this molecule is a neutral molecule, so we have to again add this word here, that is K3FeCN6 is a neutral compound, therefore that is equals to 0. Now we just put the values here, that is 3 into oxidation number of potassium considered to be plus 1 plus oxidation number of Fe will be equals to x plus 6 into oxidation number of cyanide ion equals to minus 1, which is equals to 0 1. Therefore plus 3, okay, that is x minus 6 will be equals to 0. Therefore x minus 3 will be equals to 0, as minus 6 plus 3, that will be equals to minus 3. Therefore x will be equals to plus 3. So the oxidation number of a iron in this particular coordination compound is a plus 3. So you can write down that statement. Now let us find out whether that neutral molecule, whether this molecule is neutral or not. One plus 3 minus 6, okay, plus 3 plus 3 plus 3 minus 6 plus 3 plus 3 plus 6, and this is minus 6, which is cancelled out. So this molecule is a neutral molecule. Now let us consider the next example, example number 7. Okay, H2O 5 times, then NO plus 2 plus 2, okay, plus 2 is the charge on this particular coordination compound one, which is generally known as a coordination ion, as it is having a charge. So already I have told you, whatever the entities except this metal atom, these are nothing but your ligands one, and ligand have tendency to donate the electron pair to the Fe atom one. Now here you have to consider the nature also of your ligand one. Now let us start with this solution, so you will get all the point. Here obviously we have to find out the oxidation number of your Fe here, so you can write oxidation number of Fe equals to x, okay, then oxidation number of H2O, water molecule is neutral in nature, therefore its oxidation number will be equals to 0. Then next, the oxidation number of NO plus will be equals to charge on it, that is nothing but plus 1. It is very simple. Then after considering all the entities inside the square bracket, okay, that is nothing but coordination pair. So here we have to consider the Fe H2O 5 times molecule plus NO plus 2 and plus 2 charge on this particular coordination compound is a cationic entity, okay, cation. Therefore its oxidation number will be equals to charge on its, the oxidation number of all atom in the polyatomic ion equals to charge on it, okay, that's it. Now write down equation. Hence, okay, we can write the oxidation number of Fe plus 5 into oxidation number of H2O plus 1 into oxidation number of NO plus, which is equals to plus 2, okay. Therefore oxidation number of iron equals to x plus oxidation number of your water molecule, which is equals to 0 plus 1 into oxidation number of NO2 plus equals to plus 1, which is equals to plus 2, okay. Therefore what it will be equals to, that will be equals to x plus 0 plus 1, which is equals to plus 2. Therefore x plus 1 will be equals to plus 2. Therefore x will be equals to 2 minus 1. Therefore x will be equals to plus 1, okay. So you can write down the statement, the oxidation number of number of Fe in FeH2O 5 times NO plus 2 plus is equals to plus 1. Okay, now again tally this one, whether the oxidation number of this particular coordination cation equals to plus 2 or not 1. Now we have calculated the oxidation number of Fe as an plus 1, therefore plus 1 plus, I will write it as an 0 plus NO2 plus 1, which is equals to, that is nothing but plus 2 charge. So therefore this plus 1 plus 1 plus 2, so this is equals to charge on it. So this is about your some challenging and the interesting examples one. Thank you for watching this video. See you in the next video.